Don't you dare, space-time. We just figured out the electric the electric ladder, man. We just did the electric ladder and the electric bull coffin, man. Come on. A Sharps was in here. I don't want to have to do this again.
Want to ace your classes?
Never.
Our step.
If you've studied any physics, you know that like charges repel
Didn't
and
even matter.
opposite charges attract.
Didn't even matter.
But why? It's as though this thing, electric charge, is as fundamental a property of an object as its mass. It just sort of exists. Well, it turns out that if you dig deep enough, the fundamentalness of charge unravels. And many things, including mass itself, unravel with it.
Superpositions. Well, I probably
Although
should read
many
that.
mysteries remain in physics,
Anyways.
at least our understanding of electricity and
I
magnetism
know,
seem
right?
pretty complete.
First time I'm going out watching
Math
this.
that describes it, Maxwell's equations, or quantum electrodynamics
This so far,
seem to
I
wrap
don't
it up
have
nicely,
the other stuff. We
except
could get
that all
the
of electromagnetism is powered by a single property, electric charge, and neither
Pharma.
Maxwell's equations nor Q-edd say a thing about what electric charge
Okay,
really
so
is.
we built into
It seems to be
some.
just a property
I wanted
that
to start you with
particles
logic and a
can
counter,
have or
some
not
basic
have.
types of ands and
That's
ors, and when
fundamental
they
as
would do
mass.
certain things to do a
Like,
certain purpose
we've got
instead
to
of just the
exasperated
logic.
end of the child's
that-
train of, but why? But
Built-
why?
but why?
When the only answer is just because.
Because I missed
The
that spring
idea
right
of
there.
Fundamental
And therefore,
feels like the physics version of just because. But actually, in the case of electric charge, we have at least one or
you're
two
not
more
getting this other
but
stuff with
whys
it, and you
with
have to
which
kind
we
of
can
build to get
annoy
to it.
the
Like, take your time,
universe.
build
Today,
building
we're going to
blocks.
ask
They're
them,
not going to be in this
and the
order.
answers
Hopefully,
will take us
while
through
you
the birth
take
of
this
particle
electric
physics
ladder
and, in
experiment,
fact, through the birth of the
Milgram's
universe itself.
marshmallow
As
acid
with much of
trip.
modern physics, this story begins with Werner Heisenberg, whose epiphanies birthed quantum mechanics.
Anyways, we'll get that.
At
We'll
some
be back
point,
to that.
Heisenberg turned his remarkable intellect to the newly discovered neutron.
Put this 45
He
in there.
was suspicious of
Close
its
it up.
similarity to the proton. They're practically twins in the atomic nucleus.
You get a
occurring
good
with
bull
similar
farmer that
numbers
can't
and almost
handle
the
this
same
question about
mass.
why it's
With
important
the
to
only
training
major
your kids
difference
to the
being our
ASVAB on
mysterious
that field
friend,
trip to the
electric
city of the
charge.
ratio at Dave's
The neutron seemed like a
PRT.
chargeless or neutral
Distances
proton,
and
hence the name.
directions.
Heisenberg wondered if the two
They matter,
particles
but
were
they don't
in fact
matter.
just different
We
states
don't
of a single
need them
particle, which he
in
called
this.
the nucleon. Now, at this point, we already
But we
knew
need-
of
gotta have-
particles that
gotta have
had
numbers, man.
internal states. For example, electrons have this thing called spin, a quantum
So this is a real fun way to
analogy
do this.
angular
And again,
momentum.
real simple
Spin can take on
sigma to
discrete
the
values in the electronic and
electric
possible minus
electric
a
field
half,
1, electric
loosely
field
corresponding
2
to the
because of
spin
these things
axis
right
being
here.
aligned
And
or
why?
anti-aligned
Oh
with your
man, I
measurement
wish I could
device,
do better at
which
it
we'll
because
call up and down states.
ohms the resistance.
And spin is conserved. Flip an electron
But I'm
spin
like,
and the difference has to
I can
be
get way up the
transferred
ladder.
by a photon. So, if the protons and neutrons are just two states of the same particle,
And realistically,
Heisenberg
again, when you're
reasoned
doing,
that they
I have,
may be
I want to
differentiated
charge,
by a property analogous
understand
to spin, governed
whatever
by
that
analogous
is. Now,
mathematics.
again, to these other
Thus,
charts
in
that we could
1932,
throw up,
Heisenberg proposed a new
that
fundamental
becomes a
property of
space.
matter,
Like I talked about it
isospin.
with
The
our
contraction
pawn
of
is to
isotopic
open up
or
the door.
isobaric
First thing you do is
spin,
hit your
depending
corner.
on who you ask.
That's
In
write
this
out
theory,
some
the
kind of
proton
question,
would be
draw the
in the
diagram. You have to
upstate
identify
with
the problem.
isospin
We're
half,
going to
and
change the
neutron
field
would
of
be
that
in the
problem,
downstate
change some
with
scales
isospin
with it, get
minus
it
a
to
half.
a quantifiable
By
state,
introducing this new
and then we're going to work
quantity,
a
Heisenberg
process
started to
of
make sense of the relationship
Alice and
between
Bob
protons
up
and
here
neutrons.
and
For
how you
example,
do the
with this
adding and
choice of their
subtraction,
relative
which
isospins, it made sense
can
why
get
nuclei
really,
preferred to have
really
roughly equal
complicated
numbers
if
of
you don't
protons and
have
neutrons,
a
and at the same
photo,
time allowed
a
precise
photon.
predictions of the outcome of collisions between these particles. But for isospin to really do its job, it needed to explain the most obvious difference between protons and neutrons, which is to say, electric charge. Charge would have to depend on isospin, which could mean that charge is
We
not
want
a fundamental property after all.
these bad
Fast forward a
puppies
few
right here.
decades, our particle colliders advanced,
Yes.
leading
And you're
to the
looking
discovery
at
of weird new particles. So many of them, in fact, that physicists struggled to make sense of this so-called particle
this.
zoo. But there were some clues.
You're looking
For example,
at
some of these particles had
a
very
negative
similar
or a negative,
masses,
a
but very
positive,
different electric
point,
charges,
a magnetic
which I
point.
hope reminds
There's a
you of
different
the proton
field.
and
I'm
neutron.
not good. You
So
help.
maybe
Help,
each of these
boss.
groups were really a single particle in different states with different
Big current.
isospins. The case for isospin was solidifying. But what
and we
exactly
can
was the
idealize
connection
that
between
with
isospin and
I
electric
as a real
charge?
bunny hunter.
Well, that
Like, I'm gonna
mystery
give
was
you
solved
numbers about, we always play the
independently
current,
by
right?
Kazuhiko
That's that bunny
Nishijima
rabbit
and
scuttering
Murray
off.
Gell-Mann.
Here's
Peering
what
into
we
the
know should
depths
have
of
been the
particle
number
zoo,
of
these
what
scientists
I'm looking
noticed
at them
another
negative,
pattern.
and the
There
negative
seemed to
skitters
be
off for a
family of
positive
particles that
reaction.
were created
Tells
only
me
in pairs,
why
similar to
it
how the
might
electron and
be
positron
the
are only
photon goes
created in
back
pairs
to this,
in order
but
to
their
conserve electric
positive
charge.
attitude that hasn't
But
broken
these
off.
new
And again, I
particles
might
weren't
need to
doing this to conserve
do
charge,
science with
nor
scientists to make
isospin,
sure
nor
that
any
this
other
is
known property. This suggested
not
a brand
too
new
beat
conserved
up
quantity,
or
which was altogether
correcting,
strange.
because
In
it
the
would be a
same
bunch
way
of
that
them.
isospin followed the same mathematics as regular quantum spin, this new property
This stuff
seemed to
again,
obey the math
super
of our
critical.
old friend electric
I mean, it's
charge.
gonna help,
They called
even
it
though you never
hypercharge.
know.
Nishijima and Gell-Mann then discovered an even deeper pattern.
Okay,
Electric charge, isospin,
so
and
let's get back to
hypercharge
some of the.
were intimately connected
Let's get back
across
to the
all
new stuff
particles.
inside
In
here.
fact, it seemed that
Yeah,
electric
as we
charge
do the
was
Army
just
do, and the
isospin
ASVAB
plus
and
half
the
of
Putin
hypercharge.
here, whether there's
To be
there's
pedantic,
6,
that's
10 to the
the
negative
Z
6.
component of isospin, but we'll
I
put
I
that
can do
complication aside for
6
now.
like this, but
The
I would need to
conservation
do
of
compression
fundamental
different.
properties
I was in a different
defines which
phase
interactions are
for
possible and which
100,
are
not
impossible.
120, right?
Charge
You know,
alone
kind of breaking
couldn't
it down
explain the
into
patterns of interactions and
what
particle
its
types
components
observed
are,
in
and these
particle
guys
zoo.
did really good, and I picked
However,
up on it, changed out the
hypercharge and
order.
isospin
Didn't just
seem to
look
do a much
at one
better
of the
job,
tests, broke down a
suggesting
bunch of
that
them,
these
and
may in
figured out
fact
what
be more
order they
fundamental
needed to
than
be
charge.
in off of.
But there
And
remained a
students on a
mystery.
field trip,
Not every
real thing,
combination
you
of
find it out there,
isospin
most
and
of his work,
hypercharge
but they were
possible.
all
It
over.
was Murray
These
Gell-Mann
two
who
were close,
first
but I
noticed
needed
this,
to do some jumping
plotting
around.
particles according to their isospin and
Before you get
hypercharge
to the ratio
revealed
into a town or
peculiar
wide directions
geometric
of certain
patterns.
businesses
For
or
example,
concepts
some
or
groups of 8
signs
particles
or
formed
cosines or
hexagons.
whatever
One
you're
group of
doing
10
have a
particles
field,
formed
and
a
as soon as we
triangle,
identified it as
except
such,
that the
it
triangle
created a
was
force
missing
against
the
it.
bottom
In the
corner.
real world,
No big
oxygen,
deal.
hydrogen,
Gell-Mann just
iron in the pipes,
hypothesized
whatever you
an
got.
undiscovered particle, the omega baryon,
We'll get back to
with
that.
the right isospin and hypercharge to fill that hole. Sort of like how Mendeleev had used holes in the
Cling,
periodic
cling,
table
cling,
to predict the existence of unknown elements.
Yes, here
And
we
when
go.
the omega was discovered by experimentalists,
This right here is my hydrogen
Gell-Mann
gambit.
got
Like I
his
said,
Nobel
you're gonna
Prize.
fundamentally
Isospin and
figure out its part.
hypercharge
Okay, you
seem to
know
be
all that now.
deeper
And now you
than
get to
electric
these
charge.
computer parts
But the geometric
that
relationship
still
between
have
these
that
two
same
properties
hydrogen
hinted
gambit, right?
that there may exist
It's
even
just, I
deeper
need a
physics
multimeter,
yet,
or else I have to build
even
one.
more
I need a
fundamental
power source. Oh, I
rules
have to build
which
one.
explained why they
Cut
should be
off the tail on
constrained
this
in
thing.
these ways.
We are using
Again,
this,
it was Gell-Mann
this,
who
one of
figured
these,
this
one of these,
out.
and we'll get to the
He
smaller
recognized
scopes.
that these patterns
But
were
at these
actually
levels,
representations of
they
a
don't
mathematical
need them
symmetry
exactly yet.
known as
I'm still trying to
SU3.
do a single stage
Unfortunately, we can't get
delay
into the
or...
gory details of symmetry groups in
Ooh,
this
wrong
episode.
way.
But in
Over
short,
here, sorry.
Gell-Mann realized that he could make
Thinking
sense
banger.
of the geometric symmetry if nucleons themselves were not
Okay,
elementary
string
particles,
theory
but
inside
rather
here.
made up of smaller components.
I feel bad because I didn't get the
which he
spring
dubbed
snare in on it, but
quarks.
we could always do another page
Showed
for the
that
Dakota
isospin
Hole
and
or
hypercharge were just
Wise
emergent
Plumbing,
properties
and
that
we go back to
reflected
Bernoulli. I got
different
him in a
types
different
of quarks
spot.
that make up
Whoa, no.
one of these
Whoa.
particles. Starting
broke
with
the universe.
experiments at the Stanford Linear Accelerator in 1968, the reality of quarks quickly became
Bernoulli.
conclusive. So after all this hard
This is
thinking,
that rabbit
it
jumping
turns out
around
that
on you,
isospin and
isn't it?
hypercharge were as much mathematical abstractions as was electric charge. There must be something deeper, something that lives
Bernoulli.
in the hearts of these quarks and other elementary particles that governs these differences between particle groups, and that also
Gotta
governs
jump the
electric
universe
charge.
like this.
The quark
Oh,
model
we are
for
here. Wait a minute.
nucleons
We went
led to a
wrong
description of the strong
direction.
nuclear force
We
via
wanted
this
this.
SU3 stuff to give us
Back,
quantum
back, back,
chromodynamics.
Back.
But that's a story for another time.
Oh,
It
phew.
may seem like the strong force led us astray, but actually it points to the answer. For one thing,
It's different,
the early approaches of Heisenberg
but
and Gell-Mann and
sometimes you
others
need a house
are
dog,
exactly
not a wolf,
what we
because it would be
need.
weird, right?
It's just that they
Catch you
were
next one.
applied